So in this lesson, we're going to look at how we can answer questions about saving money using a TVM solver. Now you're probably wondering what a TVM solver is. Well, first of all, TVM stands for time value of money. And a simple TVM solver can be used to solve all sorts of problems involving annuities. It can solve all the problems that we've looked at in this course so far, pretty much. And it's going to be able to solve a bunch of other questions in personal finance that we're going to look at later on. Now, you can use whatever TVM solver you want. I recommend the one here is a very good one to work with. And if you want to follow what I'm doing, that's the TVM solver I'm going to work with. It's actually the very first link you get, I believe, if you Google TVM solver. So you want to bring that up as you're working through this lesson. That'd be a really good idea. And I'm going to bring it up on my screen in a minute too. So let's look at the first question. Sam puts $20 per week into a savings account that pays 3.2% interest, and that's compounded weekly as well. He does this for all 4 years of high school. And we're looking for the final value in his savings account. Let's assume he does it for exactly 4 years, $20 every week for 4 years. So you should know by now that one way we can solve this question is by using the future value formula. So we could use the formula to solve for this. R is 20, I is our 3.2% divided by 52, N would be the number of weeks in 52 years, and so on. But we're actually going to use a TVM solver to do it instead. So we're not going to use it in this case. We could, but we're not going to. So if I pull the TVM solver up now. Okay, so here is the TVM solver. There are two modes, end and beginning. We're going to make things simple. We're going to keep it on end. What that means is if you're talking about, for example, weekly payments, are you making the payments at the end of the week or at the beginning of the week? So we're going to assume that you make them at the end of the week, meaning that the last payment you make is on the very last week of high school, and it collects 0 interest, and then we get the final amount. So don't worry about that too much right now. You can just leave it like that. Okay, present value doesn't apply in this example. So we're going to set the present value to 0. You could think of present value as being the starting value. Well, if you're going to put away $20 a week for every week of high school, your present value is 0. The starting amount is 0. The payments are the payment amounts you're going to make. So we're going to pay, the payments here are $20. So I'm actually not going to put 20 in, I'm going to put minus 20 in. A TVM solver likes to know whether you're talking about making payments or receiving payments. So we'll put minus 20. If you forgot to put minus 20 in there, you'd actually find out it still works, but that's fine. We don't know the future value. That's actually what we want to find out. We do know the interest rate. In this example, we said that the annual interest rate was 3.2. And in this TVM solver, you put that in as a percent, not as a decimal. The compounding period was weekly. So that, sure enough, is one of the selections you can use here. Now the periods. The periods is the number of payments that you make. So in this case, that's 4 years, 52 weeks in a year. So 4 times 52 gives you 208. So there's actually 208 payments of $20. To use this TVM solver, you then go to the value you want to solve for, in this case, the future value, okay? And we click on the future value button and it's going to solve it for us. So hit the future value and I get the answer of $4,436.52. So that's how much money you would have. And that's your answer for part A. Now notice if I forgot and I had made the payments positive 20, it still works. You just get a negative future value, which is kind of strange. That doesn't really matter. For the last part of this example, we're going to calculate the interest earned. It's a good idea to understand how to calculate how much interest is earned, just because it's nice to know, but also because it kind of gives you a sanity check to make sure that that answer seems reasonable. So the interest earned would be, we start with the amount, 4 years, $4,436.52. That should be more money than what we put away. The student put away $20 a week, and they did that 208 times. So in the brackets there is the amount of money that this savings account, sorry about that, probably couldn't see that, in brackets there is the amount of money that this student put away, which should be less than what they ended up with because of the interest. And in this example, I get 276.52 for interest. That seems pretty reasonable to me. You're not going to make a whole lot of interest in 4 years when you're saving the money kind of slowly and not a very high interest rate either. In our next example, we have Rhea, who plans to retire in 30 years. It's good to think about retirement early. Usually, it's a good idea to think about retirement as soon as you start working. So she's going to make equal monthly payments into an RRSP to save for her retirement. The RRSP is predicted to collect interest at 4.75% per annum, and she wants to have $600,000 in savings when she retires. Now, as I mentioned, I'll end up mentioning this a few times, we are going to look at retirement savings plans kind of on their own. I'm just introducing them a little bit at a time. Okay, for now, all you really need to realize is that an RRSP is a way of saving for your retirement. Okay, so this question, again, you could use the formula to solve for it. We're looking for the monthly payment. So you could use that R equals FV times I, all divided by that mess of an equation that we worked on earlier today. But we're going to answer this question using the Tvm solver. So let's look at that. Okay, back at the Tvm solver. You can hit the reset button just to reset everything. Okay, present value, again, we set that to 0. The payments we don't know. We do know that we want her to have 600,000, so we're going to put 600,000 in for the future value. We talked about the annual rate of interest being 4.75. And the periods, well, she's doing this monthly for 30 years. There are 12 months in a year. 30 times 12 is going to be the number of payments she makes, which is 360 payments. And now we calculate what payment amount does that need to be. So of course I figure out the payment just by clicking the payment button, and we get
$754.88, and of course that's a negative because it represents money she's paying, and that's our answer. So there's our answer, $754.88 per month for 30 years to have $600,000. And later on we'll talk about what happens with that $600,000 once you have decided to stop working. You don't need it right away. You don't want to spend all your retirement money on one day. Okay, now let's suppose we'll continue with this example that Rhea decides she can only afford $500 per month. So she's not going to save $754, it's just going to be $500, and she still wants to retire with $600,000. So she's decided that what she will do is she will just take, sorry if you couldn't read that, she will just take a longer time to solve for her retirement. So actually the Tvm solver is fairly powerful because it allows us to solve for any variable we want, including time or your n value, which we couldn't do using the equation, at least not with the math that we know how to do. So let's go back to our Tvm solver. We'll figure out how long this is going to take her. Okay, so we don't need to reset everything. We know the payments are now going to be negative 500. We don't know the periods. Everything's still monthly. The final value or future value is still 600,000. We just don't know what the periods are. Once everything else is filled in, then we can click periods to figure it out. So I click periods, and I get 442.78. So she's actually going to have to make 443 payments. The last payment just won't be as much as the other payments. So to keep things simple, we'll just use 443 and know that the last payment's going to be a little bit less. Okay, so 443 payments or periods. Now we need to know in this example, those payments, they actually represent months in a year. So we might want to know how kind of an idea how long that is. So one thing I'm going to do is I'm going to take 443 and I'm going to divide it by 12, which will give me an answer in years. Okay, and that answer would be, let's see, 336.9 Okay, so almost 37 years as opposed to 36 years. Sorry, almost 37 years as opposed to 30 years. So you can kind of see the benefit of like, $500 a month compared to 754. That's 7 years sooner you would reach your goal. So it makes a big, big difference. And we'll talk about some of those differences later on. We'll look at how some of the numbers work out for retirements and mortgages and all that kind of stuff. So there you are. So that's our last example in this fairly short lesson. I mean, the main thing to understand right now is when you're using the TVM calculator, you want to fill in everything but one variable that you're going to solve for. And for the examples we work on savings, your present value is 0. Now, if you wanted to, you could actually change the present value to something else, and then it'd be like you had a starting amount basically, and you're just saving on top of that, building on top of that. Okay, thanks again for tuning in.